You're not going to want to miss this episode of the AI Show where we talk all about MLOps V2, unifying MLOps at Microsoft. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking all about MLOps V2, unifying MLOps at Microsoft. I have two special guests, Mo and Setu. Hello, my friends. Why don't you introduce yourselves? We'll start with you, Mo.
Hey, very good to be here. I'm very excited. So Mo Steller, I am the chief architect and main designer of the solution accelerator MLOps V2. Happy to be here. Setu?
Hi, this is Setu from warm and sunny Singapore. I'm a colleague of Mo doing the same MLOps piece and building up the solution architecture.
Fantastic. So here's the thing that I want to start with, because we hear MLOps, but sometimes it becomes a little confusing as to exactly how we should think about it. So Mo, we'll start with you. Why don't you take us through how one should think about MLOps?
It's how much time do I have, right? So that's the first question, right? So it's really like a process of platform, people, and overall processes of an organization, essentially, on how to design a system that helps you to operationalize ML models or any type of artificial intelligence with a particular tool stack. So you see my sentence is already very long and very convoluted. And so that's the main challenge really with MLOps, why it is sort of like an unsolved field. Everybody talks about it, but then there is something new every month that comes out. So, and today we are here to give you a solution essentially that helps you to solve this really hard problem.
Awesome. Well, do you have something to show us or something to get our frame of mind in the right way?
Of course. So what we are talking about today is MLOps V2, and I'm here with Setu, who really helped from a development standpoint to support this effort. So we're two of the heroes basically that are going to introduce this solution accelerator to you, and how I'm thinking about what we can cover sort of over the next couple of minutes is talking about what fundamentally MLOps is and how it translates into these techniques, basically that help you to enable MLOps at scale in a modular and very secure way. So I put up a small definition of MLOps, how Microsoft kind of defines MLOps. There are certain types of variations out there, and I don't want you to get hung up on this particular definition. This is a definition that helps you to enable and really define MLOps in your organizations. But if you're working in a particular industry, for example, the definition can look a little bit different. And that's what makes it really so hard. Everybody has like a slightly different understanding of it. But again, this is the view of how we are interpreting it with our tool and our solution accelerator that we have built, unifying MLOps at Microsoft.
Awesome.
If you're looking, so to speak, at the state of MLOps, we sort of have these 5 big areas available, and they're really concepts in itself. And you can kind of already say that in the train model piece and then the package model piece, you probably see more like a data scientist type of persona, maybe also in the validate model. But when it comes to deploy and the model monitoring, other personas, such as an ML engineer or like a DevOps engineer or whomever is available, depending on the size of the company, is really becoming important there. And you see that with this very simplification here, that many people actually take part within an MLOps process. And when we see these type of diagrams like this, I just can say as a data scientist, I think myself, this is easy. I can do this all myself, right? I write Python pipelines and I'm good to go. But the really rude awakening is that this is a hyper complex process with many different tools, CI/CD tools, standard and practices, basically, that apply individually to each of these brackets, and then overall automation tools that help me to enable security and scalability of models.
That's cool. Yeah, and like I said, it's a process, and it's cool that you're laying it out this way, because I feel like me as a data scientist, field type guy, I love the model part, but that's not where all the value is, and you extracting it this way is pretty cool.
So Seth, this is what I always going to say, right? The modeling is the easy part, and it's like the smallest percentage in the overall pipeline. So I like the modeling too because it's exciting. You can dive into algorithms. You have all the nerdy talk going on. But really the other, I almost want to say 90% of the work is operationalization, standards, practices, solutioning. How does it fit in the enterprise architecture? There are so many questions around this that can be very interesting, but it's not really like this sexy type of work, essentially.
Right. Yeah, that makes sense. So here's another question, because I noticed that in the title it's MLOps V2. Can you explain the V2 part? What are we talking about here?
Yeah, certainly. So within the past in Microsoft, we approached usually MLOps at scale in very different variations. So many smart people had many really good ideas. But sometimes if you talk, let's say, to a healthcare customer and a retail customer, the solution that was built for either or was not really a fit. And we kind of understood that because of these variations of technology stacks and also the variation of AI workloads, and what I mean by that is NLP, CV, and classical ML, we really needed a very modular solution, essentially. So when we basically morphed from MLOps V1, you may say, to MLOps V2, and I don't want to make this a product term here, more like a evolving state, we were able to create an asset that can dynamically create a system for you depending on your choices. So think about a large Cartesian product where you decide, I want this, 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 this. I throw it in a box, and then you have a shipped system. So that's the big new thing here.
Awesome. I love it. I love it. Well, what else you got to show us, my friend?
Yeah. So I want to show you a little bit the value proposition of what's going to happen within MLOps V2. And I always like to start off with, I guess, something funny. This cartoon actually looks like one of my dear colleagues. So I always like to show this. And it really like exemplifies the state of MLOps, of what's going on within this very complex system. So you run in error messages. It is a very, very tedious process to set up the automation of AI. Also, if you think about AI is so impactful or can like make such hard decisions for humans that are in the end, need to be monitored and need to be very closely watched by business decision makers and technical decision makers. So
that makes sense.
Go ahead.
No, that makes total sense. Like I was empathizing with the guy, that's like, wow, I got a different error message, because I have been there, as many of our viewers have as well.
Yeah, me too. It can be painful, but we're really trying to make this easier here, right? This is the end goal, that if you think about your data scientist, you want to ship your product, your model fast. You want to go fast to production, essentially. And there's so much automation in between and so much tedious work that we're trying to take out of the equation so that you're happy as a data scientist, but also your product manager is happy, the person that is responsible of getting a solution out.
Right.
So we have identified different type of challenges when we talk to customers. One is roles and skills related. So you have many different personas in an enterprise. I always like to say, as larger the enterprise, as more role diversity you have, and as more specialized the tasks are. So the project really starts to blow up, essentially, with whom works on an MLOps type of project. Second, we have this tool variation. So an enterprise may have, RStudio, Visual Studio Code, certain type of machine learning services, different CI/CD tools, container hosted tools, and so forth. So it creates this huge tech stack, essentially, that is sometimes even different from department to department. And it is really hard to say, I have developed one MLOps system and now I'm going to bring this to my neighboring department so they can benefit from the same system. Well, guess what? They use a different tool. And the work that has been done over the last month is kind of not really applicable. Thirdly, we see that in artifacts and versioning, often that there are challenges around model registries and really trying to understand how to tag models, how they can be tagged and create metadata so that people have insights in the model state, and also how to define source code that is resilient and secure for the future. And lastly, when it comes to the development and production, the goal is really to move, I just said that a second ago, move fast to product. Often data science projects are getting stuck in this experimentation iteration, which again is cool for the data scientist because you learn a lot. But in the end, for a business essentially that needs to make business decisions on AI, they basically want to move fast to product and want to be able to monitor these solutions in a sufficient way.
Yeah, I mean, this is cool stuff, and these are clearly challenges that I've seen. I'm working on a project just by myself, and there's a lot of different choices people can make just on their own. Now imagine all the other people that are involved too.
Yeah, it is really complex. I'm working with a couple of customers together here at Microsoft, right? Those are really, really large global enterprises, and they are just seeking so hard for a system that they can dynamically create and apply worldwide to any type of data science department they go, be it in finance, be it in marketing, be it on the product side, anywhere, right? And so it is just a tough challenge. And so what we have identified essentially, it really comes down to, if you're thinking from an MLOps-centric perspective, that you want to include people, and I can't highlight this point enough, because the people create the product. So we want to include the people, we want to include the process. Everybody has their own particular process, and it is very important to create an agnostic system that can take on any type of process and make it applicable back to the enterprise and the platform, so that you have tool variations you can pick from, or different type of services. So you have a very agile way of bringing basically an MLOps system at scale to an enterprise.
Yeah, again, I've always been a fan of the union of the people, process. I say product, but platform, just equally the same. If you don't have all three, it's not going to work.
Yeah, so I always like to say the 3 Ps. I'm not trying to market a new term here, but I think that works very well because it kind of refers to these 3 large pillars.
Correct. Yes.
So let's get a little bit more technical and talk about the approach, because I think that's what people are interested in. You have seen basically in the prior slides sort of the holistic motion, which is really important for MLOps. It is not just you write code and you're done. Everybody has to be somehow on board. With MLOps v2, from a technical perspective, we have 5 pillars we are realizing in this work here. First, we're offering something very simple. So in the end, if you think about, we want to have a solution where the data scientist can focus on their project and doesn't need to worry about automated pieces that they have to write over and over again. That's maintenance work for ML engineers or other type of personas that work in AI ecosystems. We want to offer a secure systems. When we're talking about secure workspaces in AML, the solution is basically comes natively secure. So this entire motion of, you have to worry about your VNet, you have to worry about, I don't know, different types of security measures. You have to build them in basically into your system. We'll take it out of the equation and we give it to you naturally and by default. We want to have a solution that is focused on speed. So I mentioned this before, that the value proposition of MLOps should really be, we're moving fast to product and not being in these 6-month plus cycles of building systems over and over and over again, and we'll never get done. So we want something that is basically repeatable at scale for your enterprise. And lastly, focused on modularity, so that you can pick, I want this workload, I want this CI/CD tool, I want, I don't know, Azure Databricks, I want Azure ML, I want Azure Synapse. So it gives you sort of like a stack of technologies and a stack of choices depending on your AI workload that makes it possible to work through a single pane of glass, essentially. And what I mean by that is really that you have a solution you can over and over and over redeploy with different type of measures depending on your personal decision. So we give the decision how you want to build your system back to you, but the entire code backend is sort of automated and abstracted for you so that your data scientists can focus on building models.
I mean, this is cool. I feel like I'm sold. I feel like I want to get into like how, like how does someone do this?
Yes.
You know what I'm saying? Like, is there like, you mentioned the approach. How should someone set up their projects? You mentioned like a template and reusability. I'd love to see the thinking behind that a little bit.
Yeah, totally. So we're currently operating of 3 repositories. We basically have a header repository that is really just a concept that we call a sparse checkout, which is an SH script where you define basically these variables of what you want to use. Do you want to use AML basically? I want classical ML. I want as a CI/CD tool Azure DevOps. I want and so forth, right? Then we have a repo basically that holds our infrastructure templates basically that allow you to deploy in Bicep, in Terraform, again, more decisions, right?
Right.
And then we have a repo, which is the third and last repo that basically holds all our project code. So if you decide to deploy an NLP workload or a classical ML workload, we give you a demo where you can see how everything works out of the box. And then you say, I want to try this myself with my own model. And you just plug in and play your own model under a certain type of conformity, I may say, having a separated train script and so forth, which are more, development standards you should need to adhere to. But you can plug it in and just run it yourself. And what you can see here in the lower part of the slide is you can basically build a project over and over and over and over again. And I can just stand here and say it over and over and over because it is just so repeatable. And the system that you basically deploy applies for any type of the personas that are part of this type of MLOps approach. And Seth, I would like to show you an architecture if you don't mind.
Yeah,
maybe this becomes more clear.
Yeah, because like I said, I'm understanding now that this is more of like, here's all the stuff, and you basically from the menu of options pull what you want, or if you know it's an NLP or a vision, you already have something you built, and you can just run it and then substitute it with your stuff. Am I getting this right?
Yes, that is correct. And on the next slide, actually, we have an architecture here. It is admittedly a little bit small to read, but the problem is that MLOps is so huge, you can't get it on a slide. And I want to just touch on the high ecosystem here. And I would recommend to you later on to look at our solution accelerator, and you can really double click and zoom in. But if you look at number 1 in the left corner, you see a data estate. This is for classical machine learning, which is agnostic to us because we say we don't care where your data comes from. You can basically use data from anywhere in your ML pipeline. Number 2 is focusing on the infrastructure. So that needs to be set up basically to get everything in place. And what I mean by that is workspaces, compute. Everything basically that goes into an MLOps system needs to be there to even work with it. And that's also templatized. And we basically, based on your choices, set that up to you. So it's like an environment that is getting built in your subscription. Versus in number 3, in your secure workspace, you basically have we call this the inner loop, your model essentially that you develop, or you can choose the demo we give you out of the box. But in here, we have the typical data science lifecycle, you may call it, or flow, where you basically build a model step by step, right? And this is really getting your tabular data from any of the agnostic data sources, then do your EDA, feature engineering, creating a model, training it, and registering it. And if you're not happy, again, you do it all over again. And you do this as long as you're getting to a step that in number 4, you're going to register your model in a agnostic registry in Azure Machine Learning, essentially. And once you are there, you kind of like end from a environment perspective, the dev life cycle, and you're ready, depending on your organization, to move forward and move this model into a test stage. So in this outer loop, which is here represented in number 5, we have sort of like this really heavy backend system, you may call it, that we give you out of the box again. So in number 6, in your staging workspace, we run basically a lot of tests out of the box. So different types of data checks, unit tests, smoke tests, tests on responsible AI, basically make sure that the quality of your model is ensured. and that endpoints can be deployed depending on if you're running batch or near real time, that they are working. And once you get all these green check marks there and your system says you're good to go, we just flip this and deploy this into your production environment with really 3 choices. So again, you have the batch choice. You can run Azure Arc on a Kubernetes cluster, especially when you're multi-cloud and so forth, or you run the online managed endpoint, which is more for near real time. So this is all great, right? Now you have your model in production. This is all done through like a YAML pipeline deployment. Everything comes out of the box, as I mentioned. Setu will demo this here in a second. And then in number 8, you basically have your monitoring portion. So that's where we basically look first at the model and the data. And the model monitoring may appear a little easier in supervised scenarios where you have a variable where you can basically compare your actuals versus the now incoming data or forecasted data and so forth. But when it comes to data monitoring, that's like something that's really hard, right? That may work on tabular data sets, but think about this. Data monitoring on images or data monitoring on language, on natural language. How do you do this, right? Those are really sophisticated concepts.
Indeed.
Where we even need to work on with research to understand how this works.
Yeah, I mean, I'm loving every aspect of this because it goes from the inner, to the outer, and then to this. There's this admin thing as well, which is our research has shown that's where people spend the most of their time. Now, you said if it's a little bit different for things like NLP and vision. How do you account for the changes in those?
Yeah, so the main difference is that some NLP tasks tend to be unsupervised. So you sort of have challenges there. So how do you basically, on a summarization model, understand data drift, right? If you don't really have a label. So that's just really hard to figure out. And there needs to be work done also from a research standpoint to get to an enterprise solution that is a little bit more abstracted in the applied AI area. And then if you look at number 9 and number 10, and I want to focus here actually more number 9, how do you retrain a model? So in this classical machine learning use case, you see that you can have, maybe in forecasting examples, you can have an automated retrain, or you trigger a new data science project where you then have a manual retrain where the arrow goes all the way back to the model deployment. But for example, in a computer vision scenario, we don't recommend to automatically retrain, rather to relabel images, which is a task of responsible AI in itself. How do you basically label? The person who labels, is this biased? But the recommendation from our side is just kick off this project again, because we have understood in the past that computer vision can be fairly complex, especially by creating training data. And to your question with NLP, this is an architecture that now focuses on NLP. So you see a little bit that the inner loop is quite different and focuses more on NLP steps to build a model. We also recommend to basically not necessarily auto-retrain if language changes over time. And let's say you're able to identify some type of drift, you often have to recreate a new corpus to fine-tune your model. And I say fine-tune here because we know the reality is in the world of transformers nowadays that nobody trains a model for the least amount of people. Let me put it this way: train a model from scratch for many months. Most people download the model, embeddings, and just fine-tune them with their own data.
Yeah, and that makes sense. And so I'm looking over there. I think it's number. Let me double check. It's number 9. I see that now there's a human in the loop as part of the recommendation. Yes. I saw that for computer vision and for NLP. Is that right?
That is right. And here again, I just want to underline this. We're working under an ethical framework. We want to ensure that the most sensitive tasks, which we define as computer vision, as we know that they are very responsible AI use cases for computer vision, but also language, where you basically have certain type of isms in language, essentially, that can introduce bias, are checked by a human. And the human in the loop in these MLOps systems is really, really important. The full automation, I can just say this personally, as one of the creators here, we do not fully support, because we want to have data scientists and business decision makers looking at the data and looking at potential bias implications of models, especially in the transformer space.
Yeah, and that makes sense. And so essentially, this is all a very cookie cutter approach with specific approaches to things that need humans in the loop too, which is really cool.
Yeah, that's correct. And I want to give it now the microphone actually to Seth. Sorry, to Setu. See, now I'm confusing you two as well. You started this earlier.
I know.
to Setu and have Setu talk a little bit more about the technical implementation so that you can see how this architecture that we are providing you, more like as a blueprint, really becomes live within your ecosystem.
Yeah, and I love that because I wanted to go to you, Setu, because I think I get a sense for what this looks like in principle, but I'd love to see what it looks like in action. Do you think you could share some of that with us?
Yeah, sure. I think Mo gave kind of a pretty good overview of what's there. So let me jump on to the GitHub and get started. Right. After all, we are all coders here, so we can get going with that.
Let's do it.
All right. So here's our page, which is on GitHub Azure MLOps v2. As Mo mentioned, right, this is essentially our header repo, right? It doesn't have any code, but it does have getting started documentation that you can work with. It also has our architectures that Mo was sharing, some very high quality versions of it. So you can zoom in, figure out if that's what it's needed. And the good part of it is we have actually, with our code, we have replicated that architecture so you can play around with the solution that we have given up and work with that. The other good part of this is, even though it's like a demo repo, from what Mo mentioned as well, you can pick and choose how you want to deploy it. Let's say you're using Terraform, we'll give you a Terraform script, or you want to use Bicep for your infrastructure, we'll give you that as well. You want to use CLI, or some people prefer SDK version of it. So all of these combinations are available for people to get started, and they can pick and choose how to get this up. So the first step of this would be go here, clone your repo and start to modify the script. So once you kind of modify the script, this is how it's going to look like. Your first few lines are going to be about, tell me what you want to do, right? So we have the first line, which talks about infrastructure. The second line, essentially about classical ML or NLP or computer vision. How do you want to kind of do this deployment? Some people prefer CLI, some prefer SDK. So we kind of give you that choice. And then give your repo a name. And all this is essentially doing is sparse checkout. Now, sparse checkout is a relatively new feature of Git. So make sure you're updating your Git version to the latest one so that you'll be able to use it. Otherwise, you'll run in all the bunch of errors in there.
Of course.
All right. So once you configure your script the way you want it, now this will create a custom code for you, which you can then, push it into your own code repo. Right. So I've kind of given that, my new project name is going to be MLOps test. And, I'm kind of doing it on my personal repo. So it's going to be Setu C. Right. So it's going to kind of push that code for you. So again, make sure you're setting up your Git and everything so that it's good to go. Now let me run the script. It's not going to push the code out there, but it will show you that, just the steps that I kind of mentioned, it's going to kind of quickly configure it to the settings that you have given. And now you are good to go, right? Now, what all code it has code for infrastructure, right? So now you can set up your infrastructure the way it's shown in the architecture, right? You have a secure version, you have a non-secure version. With your different types of environments, you have a dev environment, you have a prod environment. You can kind of set that up as well with your Python code, right? The CLI SDK version of it, right? Of course, it's not going to push it, but you can kind of start to get to that. Now, let me go back to GitHub and show you how it looks like. And once I kind of push the code, I've done it a while back, and you get a code that's good to get started with. Now, the way we kind of did this is kind of kept it in a very, very configurable manner. So, like we said, we have two environments, dev and prod, and you can configure your names in here, right? So make sure some of these names are unique so that, when you kind of go out and deploy it, it's going to kind of work through that.
Right.
And you kind of give your names to your namespace, your postfix, and, if you want, feel free to configure any of these things, right? So once you set this up, now you're good to go. Right now you can say, okay, let's build our pipelines and deploy our infrastructure, deploy our model training pipeline, so on. So let me walk you through that. Now, before I set up my my pipelines and everything, I need to make sure I have my service principles set up so that the pipelines can do what I'm asking it to do. So again, I set up 2 of them beforehand. Again, in the start getting guide, it kind of walks you through the step of what permissions you need and how tight or how loose you wanted to keep it, right, depending on your organization needs. So you set up your service connections. I've also set up my GitHub connection because it certainly needs to pull in the pipelines and the codes for it as well. So once you do that, now you're good to go. So let's start with adding a new pipeline, right? I've already connected my GitHub, so I don't need to get started. Now I say that, my MLOps test, my new fresh repo that was created by the cookie cutter is now ready. I can, start to use this. Now I've picked up my repo. Now it's going to ask me, where are my pipelines, right? Do you want to start with new or you want to pick existing ones? And the good part is we give you existing pipelines to go with. So we are going to pick the last option in there, existing pipelines, which I already have in my YAML files. And you will find a bunch of them that are in there, right? A good way to kind of look at it is, understand, if you're looking at your DevOps for your models, it's going to be sitting in there. And for your infrastructure, we have sitting it in the infrastructure pipeline. So I'm just going to pick that just for the demo, and it will kind of show you the editor part of it. Now, let me just take a couple of minutes to kind of explain, how we kind of did it. I kind of modified it for our demo here today. Now, some people might have more than one environment, right? So depending on how you're promoting your model, how you're promoting your code, we are showing you a approach of doing that, right? So now instead of working with your approvals and everything through Azure DevOps, I'm sure a lot of DevOps engineers know how to do it. One approach that we have here is do it via GitHub. So when your code gets promoted, you're kind of working with the latest code in the specific environments, and I can pick up the names from the YAMLs that I showed you earlier.
Got it.
The other cool part of it is a lot of these are reusable templates, which also sit in a separate repo. Because a lot of times you're going to kind of reuse those steps over and over again. And imagine, right, we love to copy paste, right? And, and a lot of times, a lot of errors are introduced because you're copy pasting them. So what we have done is now you have a template in there. So instead of saying that, okay, create a resource group or, connect to a workspace for every step that you do, you can just refer to a YAML file, and then it will kind of just copy those steps from there. So in a sense, right, for organizations, you can create a more structured way of how your organization does MLOps. And this is one of the suggested component approaches that we have adapted for this MLOps steps.
This is cool. And so basically this is setting up the full infrastructure that you would need to run the whole thing.
Yeah, absolutely.
That's cool.
Yeah. So once you set this up, run it, and I kind of did my pre-work. I baked the cake ready, so on the TV it looks good. So I do have my infrastructure, the one that I was just deploying so far. I did my model training, online deployment, and batch deployment. Let's just dive a little bit deeper into MLOps model. Now, when we kind of go in there, right, I ran it a couple of times and I wanted to show you how, right? So what it's taking is, it's taking my data that I already have, going through what we call as inner loop steps of preparing the data, cleaning it up, training it, and, creating a model out of it, right? So it's doing all these steps for me. And let me show you how the pipeline really looks like, right? So now I have, I check out my code, I install the AML CLI, connect to Azure Workspace, and then start running my job. When I run my job, right, you can see here it's taking about 27 minutes. This is where it's kind of setting up my compute, setting up my workspace, and running the code in there. So let me show you how the pipeline really looks like.
So as this is getting started, if you run it again, is it going to set up all the compute again for you, or is it just going to use whatever was set up before?
It's going to reuse what you have set up before. So the first time when you run it, often takes a longer time because it's setting up your compute, it's setting up your environment, but subsequent runs are much faster.
That's cool.
The other thing that I wanted to point out is, you saw that, the runs are going to be, my pipeline was running for about 27 minutes while it was doing the training. And I'm sure a lot of DevOps guys, who are watching this right now would feel a little bit uneasy. This is only for demo, right? So you can pick and choose if you don't want to kind of keep it a blocking run, right? So if you believe that, hey, once I submit the pipeline, let it run on its own and not block my MLOps runners, you can do that as well.
Yeah, that's machine learning folks are like, oh, it only took 27 minutes. That's awesome. With infrastructure too? Really? I mean, you know what I'm saying? Because I feel like you said 27 minutes and I didn't balk at all. I was like, oh, okay. It's a nice model. I mean, so that's so yeah, but the MLOps folks get upset about this, right?
Yeah, you're blocking my runners, right? Free it up, right? Just submit. You can do that. You can submit your pipeline and let it run, and it's going to go out and do its stuff. But then again, you'll have to make sure that the run is complete before you do that. Now, in my steps itself, right now, what I did was I broke it out into different components, and you can see that my pipeline is fairly, I wouldn't say complex, but there are a lot of flows going in from one place to another, right? So the good part of this is I can reuse these components that I have in another project. So somebody doesn't have to write it again, right? So let's say I have my evaluate model that I've built up, or my train model, which let's say I'm using light GBM model. I can reuse this in a different project itself. So, once you have a component, you register it, the reuse comes in there as well in your machine learning workspace too. And then you can connect it however you want it based on the needs that you have for the team as well. So it's not opinionated from that perspective, and it allows for reuse and sharing across the organizations.
So here's a question. How do you evaluate the models? It looks like you made an evaluate model component. What are you comparing against other models, or what's the evaluation process like?
Yeah. So in evaluation, we do quite a few things in there, right? So let's say you're running with a couple of other models in there, right? So the first time when it runs, it registers the model because it doesn't have any reference to compare it with, right? But when you run that subsequent run under the same experiment, what it's going to do is it's going to compare the model performance with that of the previously registered model. And let's say that registered model is in production. Now it's going to, based on certain metrics, it's going to say, is my model performing better? Yes or no. If it's not, I am not going to deploy it. Right. So we kind of use that one as one of the ways to make sure that, I'm not just randomly registering the models if it doesn't make sense. Right. So if people are playing around with algorithms, with feature engineering, and kind of developing their models, right, you can kind of still do your experiment, but only the best model gets registered. So in some sense, it kind of brings some semblance into how your pipelines are run.
And that's clever, because you said you're looking at previously registered models and comparing, because just because you train a new model doesn't mean it's going to be better.
Absolutely.
And that's really smart. I like that.
And, as an example, right, I think the screens are smaller, but you can see, in the small window of my, okay, let me try to bring it up. In a small window of mine, it's kind of also showing you the comparison. So blue one is the previously registered model. The orange one is what I did right now, right? So you can see that it didn't do well. So it's going to skip registering the model, right? So that's what is happening in my step at this point.
That's cool. Yeah, that makes a ton of sense.
And, we kind of talked about, doing this in a responsible way, right? So my evaluate model also does a couple of things. It also evaluates for fairness. And, in the whole thing of doing this, I never explained what I'm doing in this whole process. So my whole data set and the model that I'm building in here is about taxi fare prediction, right?
Okay.
So given a starting location, given an ending location, and the daytime parameters, I try to estimate what is it going to cost. And in my city for this demo, I have 2 vendors in there, right? So I want to make sure that, my model is being fair to those vendors and not being biased across that. So I use our responsible AI toolkit to kind of do that evaluation in there. So that model fairness evaluation is also done as part of my evaluation.
Awesome. And can you click, there's a little expand button right beneath job overview. Click that one right there. There, down. No, sorry. No. If you go to the, no, not that one.
Let me get back to where I was.
Yeah. There you go. So you see right next to the one that closes it, there's an expand button too. Not that one. That one. Yes. Lovely.
So in my model, right, I have set up, like I said, right, there are 2 vendors in my city, and these are the 2 subgroups that I have, right? So I've already set up the fairness. Let me walk you through, which metrics that I'm going to run with. And since this is a cost, I'm predicting a real number. This essentially becomes a regression problem. So I'm just going to work with mean square error, and what is the metric that I'm going to evaluate the model with. And I have my model, and you can see that right now I'm comparing the 2 models that I have created, and you can see that my current model does have some amount of bias in there as compared to the previously trained model, which had relatively lesser errors associated with that, right? So it's not doing good. It still needs a little bit of tuning, but it kind of gives you an idea that I can make this as part of my workflow, right? I don't have to kind of go out and do this separately. I can use my existing models and existing steps to kind of do it right in my process.
Yeah, and that's cool because then in your evaluate step, you can actually use fairness as a measure of whether something is good or not, and whether you want to put it in the registry.
Absolutely. Yeah.
That's cool.
And I also have another step that I did as part of my evaluate, which is my model explanations, right? Again, you want to make sure that the models that you're putting out are doing what they are supposed to do, and they're not looking at this. In CVs we have seen, you look at the background and it's kind of predicting where things are, right? So your typical feature importances, or whether you want to play around, right? This whole explorer is out there for people to start to play with, and this is also one of the steps that we set up for working through that. And as expected, your distance is one of the bigger factors of your cost, which is how it should be.
And this is really cool, and that's why it took 27 minutes, and it did all of this too.
Yes, as part of the whole
cool.
process.
That's really cool.
Right.
That's really cool. So
and once I have, so I did my, so once I have my, once I have done my steps, and the model is kind of registering that, and you can see that the model does get registered in the model registry, which is something that now I can start to go out and deploy as an online endpoint or a batch endpoint, right? So again, the way we kind of do this, typically people know that you write a scoring code and you kind of do your online or batch deployments. The way we have done it is through the ML flow models, which doesn't require a scoring code. Which is cool, right? Because you have built your model, you have built your pipeline. Why don't use that when you're kind of doing that? So you don't essentially require a scoring code itself. So we use ML flow model to register it, and that essentially can just go into your online or batch endpoints without much inputs in there.
That's cool. That's why ML flow is awesome, and we love it here at where we work. That's cool. So we're kind of running low on time. Any other things that you want to show us to wrap up?
Of what it can do. I have. So the next one I'm going to show you is online deployment and batch deployment. Just wanted to show you that all of these pipelines are available as part of the demo. So in the online pipeline, again, I'm not going to walk you through the steps. You can believe me that it works. You can see that I did it not too long ago. And let me open up the endpoint. So it's, as you know, for most folks who have worked with Azure, The managed endpoints are essentially what we have, which create both real-time and batch endpoints. So it has a flexibility for allowing you to scale up and down as the demand permits, right? So I have my taxi online model, which is deployed using my pipelines, and it's up and running, right? So of the pipelines, we also do the test, right? And typically people have different ways of deploying that. We have kind of taken a blue-green approach where, we kind of start with the existing model, pass a smaller data to the newer models and scale it up as we start to believe that the model is doing well. So that's there in the existing pipeline, and it will swap out blue and green depending on how many times you have deployed it. So I have a sample data in here. I'll just quickly copy it and show you that it works. And this is my real-time endpoint, right? I can do my batch as well. Batch will not keep your machines running. Only when it's needed, it will create that cluster and do its job and then throw the output, and then you're good to go.
Well,
these are the pipelines that we have, and we have more in.
Yeah, and I feel like you're lagging a little bit, so I just want to say this is awesome stuff, and we're kind of running low on time. So I want to go to you, Mo, just to finish up. Any wrap up commentary you have for this?
Yeah, so I just want to underline that we are building like these other technology patterns in there. I mentioned Synapse earlier, IoT. We're likely going to also look at a recommender solution and so forth. Azure Databricks is a big one. So this will be part of the solution accelerator overall. And then I just can say, contribute, right? This is a framework we basically give everyone. We are looking for PRs. We're looking for community engagement. We're looking for folks just to be active and help us to really build out something really big here that is unified.
I love it.
If you want to catch us at conferences or anywhere, we are always helping others to be successful there, to speak there and so forth. Please do so.
Awesome. And I'm putting the link. This is the GitHub link. It should be below for those that want to participate. Again, it feels like a very nice cookie cutter way of doing a complex MLOps process. Setu showed some amazing stuff when it comes to, even because I thought you just trained the model, and I was like, 27 minutes, that's great. But doing the evaluation on it, and then doing the fairness, that was amazing. Any final words from you, Mo?
I think from my side, I'm good. I'm really excited. That's all I can say. We worked on this for the last couple of months, and a project has its height and has its lows and so forth. And we're finally at a point that we can roll something out in a very unified way. And I can just underline this over and over again. This is something really big, and I'm excited, Seth. I'm excited.
Well, I am too. I'm going to try to incorporate it into some of the stuff I do. Thanks so much for being with us, Mo and Setu. Thank you so much for watching. We're learning all about MLOps V2, unifying MLOps at Microsoft. Thank you so much for watching, and hopefully we'll see you next time. Take care.